Students, so today we are going to learn more about hydrocarbons, how to name and draw complicated hydrocarbons with alkyl groups. So let's get started. Please make sure to have your organic chemistry packet and reference table in front of you as we go through the lesson. So let's try to name the following hydrocarbons. Please pause the video and try to name it by yourself and then play the video again to check if you got it right. So for the first compound, I realized it's a hydrocarbon because we only have hydrogens and carbons. And then I realized I have 4 carbon and a total of 8 hydrogens. So if you look at reference table Q, you would realize that the total number of hydrogen in this example is exactly double than the number of carbon atoms, and therefore it has to be an alkene where the suffix would be -ene. Again, the number of hydrogens in this example is exactly double than the number of carbon, and therefore it's an alkene. Since you have 4 carbons in total, if you use reference table P for prefixes, the prefix for this organic compound would be but, and therefore the name would be butene, right? Again, we are going to use reference table Q and P to identify the name of a hydrocarbon. So if you count the number of carbons from your left side to your right side, the double bond is in between your first and second carbon, and therefore the name is going to be 1-butene. The number 1 in this case represents that the double bond which is in your first carbon. So for this compound, even though the double bond is between first and second carbon, we cannot name this compound as 2-butene. Again, we are not allowed to name the compound as 2-butene because we always have to pick the lowest possible number to represent the location for an unsaturated double or triple bond. So again, remember, always pick the lowest possible number. Therefore, if you have an option between 1-butene or 2-butene, in this case, the double bond is between first and second carbon, and therefore we will go with the name with 1-butene or just butene. If someone is counting this compound from right to left, you can see that the person might make a mistake by assuming that this compound is 3-butene or 4-butene. So if you're counting from the right side, obviously it cannot be 4-butene. You might assume that this is 3-butene, which is also wrong. And this is the reason it is extremely important for us to count from both sides, left to right and from right to left. Whichever side gives you the lowest possible number for the unsaturated double or triple bond, that's the side you should pick. So in this case, we had an option between 1-butene, 2-butene, 3 or 4-butene. We picked the lowest possible number. For the first option, if you look at the green numbers from left to right, I had an option between 1-butene and 2-butene when the double bond was in between carbon 1 and 2. So I picked 1-butene because that's the lowest number. If I was counting from right to left, I would have gotten 3-butene or 4-butene. My first preference would have been 3-butene, but then again, that is also going to be wrong because you should have counted from left to right in this case instead of counting from right to left. So always count it from both sides to understand where the location of the double or triple unsaturated bond is. We're going to talk more about some practice questions so that the concept becomes much more clear to you. For the second question, we also have 4 carbons and 8 hydrogens. So this is also an alkene. the name should end with ene. Since I have 4 carbons, therefore the prefix would be but. So the name would be butene. However, butene means 1 butene, where the double bond should be in between the first and second carbon. Here, I notice that the double bond is somewhere in the middle. And that cannot be 1 butene. So we have to reconsider the name, and we have to count from left to right and from right to left to figure out which side gives us the lowest possible number. So if I'm counting from left to right side, the double bond is in between the second and third carbon, and therefore the name should be 2-butene instead of 3-butene. Again, if the double bond is between second and third carbon, you always pick the lowest number, and therefore the name should be 2-butene. Let's take a look at the same exact compound, and let's count from right to left and to see if there is any difference in terms of the name. In this case, if I'm counting from right to left, the name is still remain as 2-butene because the double bond is still in between the second and the third carbon. So it should be 2-butene. The last example is also similar to our first example and the second example, where we have 4 carbons and 8 hydrogens. Therefore, the name should be butene. However, if I count it from left to right, it would be 3-butene. But I always need to check by counting it from the other side. So if I count it from right to left, my double bond is in between the first and second carbon, and therefore the name should be 1-butene. So if you have an option between 1-butene and 3-butene, and the double bond seems to be on your left side or on your right side, between the first and second carbon, you should always select the lowest possible number, and therefore the correct name would be 1-butene, or you can simply write butene. You don't have to write 1 because we have to assume that it is going to be between first and second carbon if there is no number written for an organic compound. You should pause the video and practice the following compounds, and then play the video to check your understanding at this point. Since we have 5 carbon, the prefix would be pent. We have 10 hydrogens, which is exactly double compared to the number of carbons. The suffix would be ene, so the name should be pentene. But if I just write pentene, that means the carbon is in between my first and second carbon. So if I count it from left to right, the name pentene would be correct because the double bond is in between my first and second carbon. So you can write just pentene, or you can write 1-pentene, and both of them is going to be considered as a correct answer. For the second question, we also have 5 carbons and 10 hydrogens, so the name should be pentene. But the difference is, for the second question, we do not have the double bond in between the first and second carbon. So if I count it from left to right, it would be 1, 2, 3, 4, 5. So it seems like the double bond is in between second and third carbon. So I have to pick the lowest number, and the name is going to be 2-pentene. If I count it from right to left, the double bond appears to be in between third and fourth carbon, so the name would be 3-pentene. However, we should always select the lowest possible number to identify the location of the unsaturated double or triple bond, and therefore the correct answer is going to be 2-pentene and instead of 3-pentene. For the third one, again, we have C5H10, so that's in pentene. and because you have 5 carbons, and if you count it from left to right, it seems like the double bond is between third and fourth carbon, so therefore I would go with 3-pentene. You should not pick 4-pentene because you always need to pick the lowest possible number. However, if I count it from right to left, this would become 2-pentene. So I have to go with the lowest possible number, and for the third one, it seems like 2-pentene is the correct answer. Again, you have to count from both sides. Count from left to right and right to left to identify which side gives you the lowest possible number for the location of the unsaturated double or triple bond. Again, for the example given in this slide, if you count it from right to left, you would get 2-pentene, versus if you count it from left to right, you would get 3-pentene. So you have to go with the lowest possible number, and therefore the correct answer is going to be 2-pentene. For the next one, we have 6 carbons in total, therefore the prefix would be hex. We have a triple bond, therefore the suffix would be YNE, so hexine. But if you count it from left to right, your triple bond is in between second and third carbon, so therefore the name should be 2-hexine. If you count it from right to left, your triple bond is going to be in between fourth and fifth carbon, therefore the name might appear to be 4-hexine. If you have an option between 2-hexine and 4-hexine, you should go with the lowest possible number. In this case, the correct answer would be 2-hexine. So what is the rule? Always assign double, triple, or any functional groups the lowest possible number in that compound. So always pick the lowest possible